Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another computer science lecture. So we were discussing section number 3.2 or 5.1 of the old syllabus, 3.2 of new syllabus, input devices. We have discussed half of the input devices. Now today we are going to start with touch screens. Touch screens work as both input and output devices simultaneously, because you can get some output from them as well as you can use them to give some input. Touch screens can be of three major technologies: capacitive, infrared and resistive. Capacitive is made up of multiple layers of glass having electric field between layers of glass. When top layer is touched, microprocessor determines the coordinates of at what point screen was touched. Whereas in infrared there are two technologies. A warmer object, for example finger, is needed to touch the glass screen in order to sense a touch. This is the heat sensitive system. And the other one is optical infrared system. A grid of sensors is deployed below glass which determines touch. On the third number we have resistive. It is made up of only two layers, upper of polyester or plastic and bottom is of glass. When top layer is touched, the circuit is completed and signals are generated which are interpreted by microprocessor to know location of touch. Now what are the advantages of these three types? Capacitive, it is of medium cost. It is usually found on medium cost cell phones. Good screen visibility even in sunlight. So if your cell phone if you are able to view the screen of your cell phone or laptop in bright sunlight, then be assured that your device is having capacitive touch screen. And it has multi-touch functionality. It is a durable screen. It does not get scratched easily. For infrared, it has multi-touch functionality. It is also durable. Optical sensor system can be used with gloved fingers and it can still be operated with the scratched or broken screen. Whereas the advantages for resistive are, it is inexpensive. Out of the three technologies, it is the most inexpensive one. It can be used with gloved fingers, stylus and bare fingers, and it has good resistance to dust and water. Whereas the disadvantages are, for capacitive, only bare fingers or a special stylus can be used to input. Sensitive to electromagnetic radiation, because this works on electrical capacitance or conductivity. So if there is an electromagnetic field around, the touch would not work. Infrared disadvantages, it is expensive. Heat sensitive system can only be used with bare fingers. Visibility is very poor in sunlight. Screen is sensitive to water or moisture. It is also sensitive to light interference. Accidental activation is possible if infrared beams are disrupted due to any reason. For resistive, disadvantages are poor screen visibility, multi-touch not possible, not good enough screen durability. It is easier to crack and easier to scratch. It can be scratched easily. Low touch sensitivity, thus sometimes have to be pressed very harder. This is a resistive touch screen and it has two layers. One is of glass, the upper is of polyester, and in between them there are dots known as spacers which do not allow the both layers to meet accidentally. When you put your finger, then because of the force applied by the finger, the upper polyester layer bends and touches the glass layer. Hence the circuit is completed. Whereas in capacitive touch, there is an electrical current in the screen, and when you touch it with your finger or any other body part, then that circuit is broken and the microprocessor detects at what point the screen was touched. In infrared touch screens, there is a layer of light emitting diodes at one end or LEDs at one end, and infrared LEDs you do not see their light, and sensors at the other end. When you touch, this forms a grid of lasers on the screen. When you touch the screen at some point, the laser is broken from at that point, and hence you are able to see over here. As you can see, this has formed a grid between the LEDs and the sensors, and when you touch it, then at the point of touch, the path of the light beam or the infrared laser beam is blocked. Hence this detector is able to detect that okay, at this coordinate or at this point the screen has been touched. And if you're this was a part of the old syllabus, whereas if you're following the new syllabus, then there are two more technologies in infrared touch screens included. So we are going to learn about that next. There are presently two main types of capacitive touch screens: surface capacitive and projective capacitive. Surface capacitive touch screens have a conductive coating on the front surface. Wires are attached to each corner and a small voltage is applied to each of the corners. When the screen is touched, a small current flows to the touch point, causing a voltage drop. A microcontroller measures the decrease in capacitance and hence determines the point where the finger touches the screen. This system only works with a bare finger or a stylus. You cannot use gloved fingers like this. On all four corners of the screen, wires are attached, whereas the screen is coated with conductive layer. So when you touch it, the current is able to flow from the corner to the point where you touch the screen or towards your finger. This causes a voltage drop at that area, and hence the computer is able to detect where the screen has been touched. See, the point where you touch, a voltage drop appears at that area. Next we have projected capacitive touch screen. It is very excellent at optical property, means it is very visible, and it has optical properties just like optical infrared. It responds to light touch. You do not need to tap very harshly or very strongly. No pressure force is needed for detection. Projected capacitive requires an advanced technology to measure electrostatic capacitance and achieve precise location information from it. This system works with bare fingers, stylus, and thin surgical or cotton gloves. It also allows multi-touch facility, for example, pinching or sliding. How does this work? The electrodes beneath the screen, they project an electrical field which is present outside the screen or directly above the screen. When somebody touches that, those rays of electrical field are disrupted or blocked by the touch or hand, and hence at the point where they are disrupted, the touch is detected by the microprocessor of the device. Next we have sensors. Oh yeah, one thing. If you're following the old syllabus and you're at chapter number 5, then 1, 2, 3 and 4 and 5. These 5 slides are not for you. You may skip them. Whereas the rest of the things are there in your syllabus. Sensors are devices which read or input analog data of physical quantities. These values are converted into digital format by an ADC, analog to digital converter, before the computer can interpret or store them. Now examples of sensor: temperature sensor, which detects what it does, it measures temperature of the surrounding by sending signals. These signals will change as the temperature changes. Example of use: control of a central heating system, control monitor a chemical process, control monitor temperature in a greenhouse. Moisture sensor. In the old syllabus, moisture sensor and humidity sensor are the same, whereas in the new syllabus they have distinguished between them. Moisture sensors measures water level in, for example, soil, air, or any other object. It is used in It is used to control or measure moisture level in soil in a greenhouse. It is used in food processing factory. And humidity sensor measures the amount of water vapor in a sample of air or a soil. Monitors humidity level in a building, monitors humidity level in a factory or a manufacturing unit, monitors humidity level in the air in greenhouse. Then we have light sensors. They use photoelectric cells that produce an output in form of an electric current depending on the brightness of the light, switching street lights on or off depending on light levels, switch on car headlights automatically when it gets dark. Then we have infrared or motion sensors. In the old syllabus, if you are following the old syllabus and you are going through chapter number 5, then you only have one infrared sensors. That is the infrared active sensor or the motion sensor. They use an invisible beam of infrared radiation picked up by a detector. If the beam is broken, then there will be a change in the amount of infrared radiation reading the detector, and hence an electrical signal will be produced. The same phenomena is used in the infrared touch screens. It is used to turn on car windscreen wipers when it detects rain on the windscreen. But the most common use is security alarm systems or intruder systems or burglar systems. In the new syllabus, we have infrared passive sensors as well. These sensors measure the heat radiation given off by an object, for example, the temperature of an intruder or the temperature in a fridge. They are again used in security system. They are activated if they detect any body heat, or they are used to monitor the temperature inside an industrial freezer or chiller unit. Then we have pressure sensor. A pressure sensor is a transducer and generates different electrical currents depending on the pressure applied. It is used to weigh lorries at a weighing station. It is used to measure the gas pressure in a nuclear reactor. Acoustic or sound sensor, they are basically microphones that convert detected sound into electrical signals or pulses. And example of uses: to pick up the noise of footstep in a security system, detect the sound of liquids dripping at a faulty pipe joint. Then we have gas sensor. Most common ones are oxygen or carbon dioxide sensors. They use various methods to detect the gas being monitored and produce output that vary with the oxygen or carbon dioxide level present. They are used to monitor pollution levels in the air at an airport. They are used to monitor oxygen or carbon dioxide levels in a greenhouse, or they can be used to monitor oxygen levels in a car exhaust fume. Then we have pH sensor. These measures acidity through or basicity through change in voltage, for example in a sample of soil. They are used to monitor or control acidity levels in the soil of a greenhouse, or to control acidity levels, or to maintain a specific pH during a chemical reaction in an industry. Last but not the least, we have magnetic field sensors. These sensors measure changes in the magnetic field. The signal output will depend on how the magnetic field changes. They are example of uses: detect magnetic field in mobile phones and CD players. They are used in anti-lock braking systems in cars, or they can be used in factories where sensitive microchips and other sensitive electronic devices are made, for example where hard drives are made. because these type of things, microprocessors, hard drives, RAMs, are very much sensitive to strong electromagnetic or strong magnetic fields. If you put a magnetic field on your laptop screen or on your computer screen or on your hard drive or on your RAM, you are going to lose all of your data, or your monitor or LCD will malfunction. Hence, it is important to install magnetic field sensors in factories where these units are produced, so that in case of any accidental magnetic field, any disaster can be prevented. Till here are the sensors which were included in the old syllabus as well, and after magnetic sensors are the list of sensors which have been added in the new syllabus. Keep in mind that the examples of use I have discussed, they are just a few, and the sensors are not limited to just these examples. You may think of, or you may search your own examples as well. Just keep in mind they should be logical. Usually the examiners do not ask for more than one example of use for a specific named sensor. Accelerometer, this is a new sensor added in the new syllabus. They are sensors that measure acceleration and motion of an application or an object, for example the change in velocity, etc. of a moving vehicle. They are used in cars to measure rapid deceleration and apply airbags, used by mobile phones to change between portrait and landscape mode. Proximity sensors, these sensors detect the presence of a nearby object. They are used to detect when a face is close to a mobile phone screen and switch off screen when held to the ear. Then we have flow or rate sensors. They measure the flow rate of a moving liquid or gas and produce an output based on the amount of liquid or gas passing over the sensors. They are used in respiratory devices and inhalers in hospitals. These are commonly known as ventilators. They are used to measure gas flows in pipes, for example of natural gas or medicated oxygen, etc. Then we have level sensors. They use ultrasonic waves to detect changing liquid levels, for example in a tank, or capacitance conductivity to measure static levels, for example height of water in a river, in a dam, in a lake, etc. Level sensors can also be optical or mechanical in nature. Level sensors can be of many types. Their basic function is to measure what is the level of a liquid or a water in a given area, or for example a lake, a dam, a reservoir, a tank, etc. They are used to monitor levels in a petrol tank in a car. Now the petrol gauge in a car is usually mechanical and not exactly electrical. In a pharmaceutical process where powder levels in tablet production need to be monitored, or leak detection in refrigerant air conditioning units. So this concludes our sensors. If you are following the old syllabus, then this level 1, 2, 3, 4 and 5. These 5 sensors are not for you, but rest of them are in your syllabus. Last input device which we have are interactive whiteboards. These devices allow presentations or images to be displayed on a whiteboard using a digital projector, with the additional functionality of storing whatever is handwritten or drawn on the board in electronic format. Interactive whiteboards can also be used to surf internet or open any software that is installed on computer. These setups are costly and may involve prior training for the person to effectively use them. Now the next part of the chapter is about monitor and control systems. In such systems, input is recorded by sensors at interval. The microprocessor computer compares them to pre-stored value. If the values don't match, if the values match, no action is taken, else a signal is sent to an actuator, an alarm, a valve, a light, a motor, etc. to perform some countermeasures. In the monitoring systems, the processor simply monitors the input from the sensors, and if any input is out of the range, then simply an alarm is an alarm is rang. For example, the ventilators in ICUs, if the patient, they are taking the vitals of patients, and if any value drops down or is higher than the normal range, then an alarm is sounded so that a doctor can come and administrate some treatment. The computer or the device is unable to administrate treatment. Whereas in control systems, once the computer or microprocessor detects that something is wrong, then the computer, according to pre-stored decisions or pre-stored instructions, the computer administrates some action. For example, if the heat is too much, then turn off the gas inlet, or turn on a fan, or turn on an air conditioning unit, etc. How does a microprocessor works with sensors to monitor control a system? This type of question is quite common in the CIEs, and this usually comes from 4 marks and up till 8 marks. So if you would be given a scenario that what type of sensors are being used, what is the scenario, for example in an aquarium, for example in a factory, and so on. So whatever description you're given, you have to take care of some points. You'll have to write your answer like this: sensors record the data from environment at specific time intervals and send it to the microprocessor continuously. You'll get 1 mark for this. The data from sensor is usually in analog form, thus it is first converted into digital form through an ADC. 1 more mark. Microprocessor compares the value from sensors to pre-stored value. The 3rd mark. If the value from the sensor is within the pre-stored range, no action is taken. 4th mark. If the value is outside the range, microprocessor sends signal to an actuator, and at this point you should quote a suitable example from the scenario given in the question, such as turning on a fan, turning off a heater, turning on an AC, etc. And for the description you write, you may get 1 or 2 marks. And if you write all these points carefully and correctly, you would get maximum possible marks. Okay, so that's it for today. In the next lecture, inshallah, we'll discuss output devices. That is the last part of this chapter or this section. Take care. Allah Hafiz. Feel free to ask me if you have any problem.